cancel out. So the 5 and the 4, they both have that same common value. There?
6 and 3.
Yeah, 6, 3, and 2 can also cancel. So Sarah, what are you left with? 56. 8 times 7 is 56. So I do want you to take your calculator out because I'm going to show you different functions on the calculator. This is one way without a calculator. So you don't have a graphic calculator, you don't know where it is, that's fine. You can still do the multiplication and do the problems. This would be considered like the old school way by hand. But there are buttons on the calculator that will enable us to do these without really expanding and kind of working through the problem. So today we're going to talk about 2 different things. The first thing is called the counting principle. And to kind of introduce you or to remind you about that, we're going to create a little tree diagram. A tree diagram starts off with essentially like your stump, like a tree, and it branches off and continues to branch off and continues to branch off. In this case, we're going to use a tree diagram to figure out how many lunch specials that you could choose from if you have chicken, pasta, or fish as a main course or a main dish. So we're going to start with that. So I'm just making a little point here. This is my trunk. I know it's some crazy looking trunk. So from this, the tree diagram branches off with your 3 main course options. So main course options, we have chicken, pasta, or fish. Does anyone know how it would continue then? Virginia? Correct. So the second option for our lunch special would be a soup or a salad. So each one of these main courses branches further into our soup or salad option. And I'm just going to abbreviate. And then Virginia, one more time.
Split into 4 for the brownie, the cake, the ice cream, and
Very good. So then each one of these soup or salad options branches off into 4 more dessert options. And again, I'm abbreviating here: brownie, cake, ice cream, pie. So you start with the main thing. The main thing would be the lunch specials. We want to find out how many lunch specials that would exist based off of these options. So how do we then determine the number of lunch specials that exist, Virginia? Alright, so these are all like our little twigs. Count all of the twigs together, count all the options together, and how many lunch specials do you have, Virginia? Yeah, there are 24 lunch specials. So that means that 24 of us could go and we could each get a slightly different option. So today we're going to be looking at different types of events. So an event in probability really is anything that can happen outside of the real world. And we'll try to be like determining how many options or combinations that we have for that given event. In this case, it's trying to figure out lunch specials. So underneath, instead of going through all of this tree diagram, which really takes a lot of time and a lot of space, there is a shorter way to do that, and that's called the fundamental counting principle. So instead of making this huge tree diagram and listing all of our options, we can instead just take the number of ways that the first thing occurs and the number of ways that the second event occurs and just multiply those two options or number of ways together. So I had 3 main courses. We can multiply that by the 2 salad or the side dish options. And then if there are 3, you take all of those and multiply them together. So the number of ways that something can occur, you multiply them together. Way easier than working through a tree diagram, especially when you're dealing with things that are larger values. So if you flip the page, first one is just dealing with pizza. So you go somewhere to a pizza shop and you want to know how many different pizza combinations you can make. This shop here has 3 crusts, 4 cheese options, 5 meat toppings, and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose from? So how would you decide how many options are possible? How many pizzas can we make? Aaron? Yeah, you're just multiplying them all together. So you're taking the 3 choices for the crust, 4 for the cheese, 5 meat options, and 8 vegetable options. And you're multiplying all those together. Now, because we're only picking 1 of each kind, so you can only have pepperoni. You can't have like pepperoni and sausage. That's why you're just multiplying them all together once. And then when you multiply those all together, you get 480 pizzas.
Why would you multiply by 3 or
Say again?
Why would you multiply by 3
That's my fault. I wrote it in the wrong one. Thanks, Sam. Sorry, my fault. So, Sam, in the next part it says if the crust was not an option, we wouldn't multiply it by 3. We would just take 4 times 5 times 8. Sorry, Sam. And what is 4 times 5 times 8?
160?
Good. So you can see the difference just by taking away 1 option. We went from 480 pizzas down to 160 different pizza options. Still a lot of pizza options that you could have or create. So then right underneath it, it says use the counting principle to determine the number of lunch specials from example 1. So we had 3 main courses, 2 side dishes, and then how many desserts were there? 4. And if we multiply 3 times 2, we get 6. 6 times 4 does make 24. So the counting principle is a way for us to determine the number of options that can occur for not only food, but for other situations like phone numbers, like your PIN number for your debit card, passwords. They now have like all those crazy restrictions on passwords. License plates, which is this question here. So if we wanted to figure out how many license plates exist in the state of Pennsylvania, we would do the counting principle. So for this question, we're using the state of Texas. It says that the state of Texas license plate has 1 letter and then 2 digits. A digit is just a number. And then 3 more letters. So that's how their license plate is set up. Our license plates, let's see, nobody's parked backwards. I think it's 3 letters and then 4 numbers.
Yeah.
I think that's what it's 3 letters, 4 numbers. So we have 3 letters and then 4 numbers. And usually that first letter starts with a specific value if it's a car, if it's an SUV, or if it's a truck even. So that first letter kind of even is more specific. But in this case, we're just trying to come up with how many license plates could occur if the digits and the letters can be repeated. So that just means that I could have like all A's and all zeros for my number or letter option. So trying to think about this as like a visual. This will be a huge license plate, but here's my little license plate for the state of Texas. Just so you get an idea as to like what you're thinking about when you're trying to come up with your combinations or your options. So it says we're supposed to have one letter followed by 2 digits followed by 3 letters. So this is kind of a little diagram so that we know what we're thinking about. How many letter choices are there? Virginia? 26. We have 26 letters to choose from in the alphabet. The fundamental counting principle says take all of those options and multiply those options together. Well, how about digits? Like, what are digits? Sam?
0 through 9.
0 through 9. So how many digits are there? 10. There are 10 digits. So I would then multiply that by 10 digits. And then I have another option for digits. So we would multiply that by another 10 options for my second digit. And then going back to the letters, again, we have 26 options for each space where a letter can exist. So you're multiplying each event, each letter or space on the license plate is considered event. You're going to multiply all of those together. This number is pretty big because we're multiplying 7 values together. So calculator definitely necessary. Sarah, what do you have?
45,697,600.
So in the state of Texas, they could have 45,697,600 different license plates. Which is good because the state of Texas has a fairly large population. So for letter B, it says how many different license plates are possible if you cannot repeat the letters or the digits. How would it change? Paige?
It would decrease by like 1 every time. So it'd be 26 times 10 times 9 times 25 times 24 times 23.
So she said each time it would decrease. So 24, 25, 24, 23. So once you use a letter or a number, you can't use it again. So that means it's taken away as an option. So Caitlin, or I'm sorry, Paige, what did you get there?
Sorry. 32,292,000.
And it's just 0, 0, 0
Yeah.
plus 0. So you can see the difference taking away that repeated option takes us down to 32 million. So we lost like 13 million options-ish. Questions? So we could figure this out for like cell phone numbers in the 412 area code. We could figure out how many different options there could be for those numbers to exist. So that is the counting principle, where you're multiplying options, choices together. The other thing we're going to look at today is called a permutation. And also a factorial. Does anybody know what a factorial looks like? So it's a symbol. Tyler?
Is it an exclamation point?
It is an exclamation point. So this symbol, what you know as an exclamation point, you're exclaiming something in English. Tyler, do you know what it does in math?
Does it multiply all the numbers that are like it's if it's like 45, it goes 40 times 44 times 43 all the way down.
Exactly. So a factorial takes your number and it essentially multiplies every number that comes before it together. So 5 factorial would really be 5 times 4 times 3 times 2 times 1. That would be 5 factorial. So the nice thing about calculators is that it has a factorial button in it so that you don't have to type by hand 5 times 4 times 3 times 2 times 1. Or 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So in your calculator, you have to first type the number in. So you always need to put the number in. So you're going to type whatever number you have. And in this case, we'll say we'll type in the 5. So we'll type in the 5. So with your calculator, let's type in the 5. Then you're going to hit the math button, which we've used before. So the math button is on the left side. We're going to arrow over to where it says probability. So all of the things we'll be working with are under this probability title. So arrow over to probability, and then you'll see the factorial symbol.
It's for 50.
Oh, all of that work packing up. So that's number 4. So you're going to hit number 4, and then hit enter, and it tells you what 5 times 4 times 3 times 2 times 1 is, instead of you calculating it out. So again, you're typing the number, and then we hit the button math. We move to the word probability, and then it's number 4 that we're typing in. The other thing we're going to work with is a permutation. A permutation is an ordering of objects. In sports, ordering is done often. So swimmers, you guys went to Brookfields, and the people who placed first through whatever went to states. I don't know, first through 3. Okay, so the first 3 of each event then got to move on to states. Hockey playoffs, I know for tomorrow night the Pens start their hockey playoffs. They took the top 8 teams, and then those top 8 teams are now in the playoffs for each division, whether it's the Western or the Eastern division. Baseball is the same way, basketball is the same way, and everything is ordered when it comes to sports and events. It matters who comes first, second, and third. Even though when you're little, they tell you it doesn't matter who wins. It's all about having fun. That's such a scam. That's why you don't keep score when you're playing t-ball until it's like 10. When you're 10, now all of a sudden score matters because there's playoffs for 10-year-old softball, and there's not playoffs for 7-year-old softball. So ordering of objects is a permutation. If you look at the top of the next page, I'm going to show you what formula the calculator is using and how to use the calculator for a permutation. So a permutation is an ordering of objects when you start with a large group. So maybe there were 50 swimmers. And of those 50 swimmers, we're taking that all the way down to the top 3. So the first number would be the large group. That would be the N. The smaller number would be the places, first, second, and third place that group would then be. So it's a small selection that you're taking from the large selection. The way we can calculate that, and this is what the calculator has already programmed in. There's a little formula that uses a factorial. So it says take n factorial, which is the large number, that large group. You're going to divide that by n minus r factorial. That's the formula that the calculator already has embedded in its memory. So in your calculator, you have to enter the n. So you have to enter the value for n. Then you're going to hit the math button. You'll go over to probability. And it is number 2, I believe. And then you have to enter the R value. So you take the first number, which is the big number. The big number has to come first because that's the large group that you're pulling from. The second number was the smaller number that's getting more specific, first, second, and third place. Okay.
What did you say the R represented?
The R would be the small number, like the number of places. So if I have 10 swimmers that are finishing just in first, second, or third place. So it's the smaller option. Virginia. The P stands for permutation.
Oh.
So that says we're doing a permutation.
So it's like the thing you calculator.
Yes, yes. So there's 2 different things. Tomorrow we'll talk about a combination. Today we're talking about a permutation. So the P shows the calculator that's using the permutation formula. And that's what the P is there. So the P isn't a number, it's just saying that the event is a permutation. So if you look underneath, it wants us to find the number of permutations. So in this first one, playoffs for baseball. In this case, there are 8 teams that are competing in the playoff or the tournament, the competition, whatever you want to call it. How many different ways can the baseball teams finish the competition? So all 8 teams have to finish in some place. Somebody has to be the winner, somebody has to be the loser. How could we figure out the number of ways that all 8 of those teams could finish from first through 8th place? Sarah? So she said the thing we just did, similar to the thing we just did. Yeah, it's 8 factorial. The reason it's just 8 factorial is because we have 8 teams and all of them have to finish in a place. So somebody has to finish first, and then second, third, fourth, fifth, sixth, seventh, and 8th. So it's just taking 8 factorial. So in your calculator, you can type the number 8, go to the math button, so make sure you're typing the 8 first. Hit math, go over to probability, and then just the factorial, so it's just 4. Or you can multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 together because you don't have this option, because you don't have your calculator and you just have your phone with you. But it's 40,320 ways. So 8 teams could finish in 40,320 different ways, which is crazy. That's like a whole bunch of options. The second question says, how many different ways can 3 of those teams, 3 of the 8 that's in the competition, finish from first, second, and third place? So because we're finishing first, second, and third place, it creates a permutation. I have 8 total teams that are competing, but there are only 3 places that we're worried about because first, second, and third place are the winners and everybody else the losers. I mean, not really, but I guess technically. You don't get a fancy little award. So if you're using your calculator, you're typing in the 8. You're then going to math, over to probability. You're hitting the NPR because this is a permutation where ordering is taking place. And then you would type in 3 because we're only worried about first, second, and third place. And then when you hit enter, it tells you that there are only 336 ways that that can occur. So it took us from 40,320 down to 336. If you don't have a calculator and you're using the formula says take 8 factorial or n factorial, divide that by n minus r, or 8 minus 3. So really you have 8 factorial divided by 5 factorial. So you just expand out the 8, expand out the 5, and then cancel all your common pieces. And then whatever's left will be your questions. So you don't have to have a calculator. It's not necessary, but it definitely is helpful. Yeah. So the other part that we're going to talk about, still working with permutations, is what happens if you have repetition. Repetition means what happens if something's repeated. So you have 2 teams that tie for a sentence. Or we have letters that are repeated in different words. And when repetition happens, it's not a true permutation. I can't just plug that stuff into the little formula using the calculator. But instead, we have to take into account the number of times that a value is repeated. So it's still n factorial. Your total number of options is always n. So the total that you're dealing with. And then the parts that are repeated, we would take, if it's repeated 1 time, and it's just s, which will be just 1 factorial. Well, 1 factorial is nothing. It's just 1. Or if it's repeated 2 times, or if it's repeated 3 times, or so on. So this would continue on and on and on. I forgot my little explanation right there. So the number of times that something is repeated is what we end up dividing by. We divide it by that repetition. So it makes a little more sense when you actually deal with like a concept here. So this one says find the number of distinguishable permutations. That just means they all have to be different. Of the letters in the word even, and then of the letters in the word California. So if we're working with the word even, and we want to find out how many 4-letter arrangements, because they're not all going to be words, can be created from the 4 letters that are in the word even. So the first thing you have to know how many letters. There are 4 letters, so that goes on the top. That's the first number, 4 factorial. On the bottom would be any letters that are repeated and how many times that letter is repeated. So Sam, are any of the letters in the word even repeated? Which letter is repeated?
Probably off guard here.
I'm sorry. Is this going to help you out? Is it?
Yeah?
What letter in the word even is repeated?
What letter?
Yes. Not a trick question.
E.
E.
I know you meant the actual word. I was so confused.
What letter in the... Oh!
Sorry.
Okay,
Did I
sorry.
need to rephrase that?
No,
No,
I don't know.
no.
What really know?
Okay, so the letter E in the word even is repeated how many times? Twice. Okay, so E is repeated twice. And that's the only letter that's repeated twice. Since it's repeated 2 times, you're going to take the 4 factorial and divide it by 2 factorial. If the letter E was repeated 3 times, then I divide it by 3 factorial. So the number of times a letter is repeated, we would divide by that number. So in your calculator, you can either use the calculator button, like you have to use the factorial button. So you have to take 4 factorial, you're going to divide that by 2 factorial. Or you can expand it and write it out by hand. So either way, it doesn't matter. So I have 4 factorial, and then I'm dividing that by 2 factorial. And it's telling me that there are 12 combinations, ways, if you just want to say ways, permutations. There are 12 different ways that we can arrange those letters in the word even. So then if you look at the word California and do exactly the same thing, California is a bigger word.
And 2 A's. There's no 2 C's. It's like
How many letters are in the word California? 10?
10.
Isa, what letters are repeated?
A and I.
A and I are both repeated
2 times.
twice, yeah. So you would divide it by 2 factorial for A and by 2 factorial for I. Any letter gets its own repetition, it gets its own factorial. So this is representing the A, that one's representing I. Does anybody have an answer? Why is it what?
Why does 10 have a factorial?
It does. I missed it. Caitlin, what do you have? 907,200.
I got 36.
Yeah, that's what I got too.
Well,
Did you divide it by 4?
So it should be 36,288 divided by 4.
That's what I meant to say.
No, you're good.
I got 280. Yeah, I got 36,288.
And then divided by 4?
Sweet, so what's the answer?
Oh.
So you're taking 2 factorial times 2 factorial, which ends up being 4. It's not 4 factorial.
Okay.
Is it 9?
That's not what I have. Okay, that's what I did.
Yes.
Wait. Wait.